A circuit breaker that trips frequently, even under normal loads, may indicate a problem. This frequent tripping suggests that the breaker is doing its job by interrupting the circuit when it detects an overcurrent condition, but the underlying cause of the overcurrent needs to be investigated. This could stem from several sources. One possibility is an overloaded circuit. This happens when too many devices are drawing current from the same circuit simultaneously, exceeding the breaker's rated amperage. For instance, if a 15-amp breaker consistently trips when a hairdryer and a space heater are used in the same circuit, it's likely an overload. Another potential cause is a short circuit. A short circuit occurs when a live wire comes into direct contact with a neutral wire or a ground wire, creating a path of very low resistance for the current to flow. This results in a sudden and significant surge in current, causing the breaker to trip instantly. Short circuits are often caused by damaged insulation on wires, loose connections, or faulty appliances. Ground faults are another common reason for frequent tripping. A ground fault happens when current leaks from a live wire to a grounded surface, such as a metal appliance casing or a metal electrical box. This leakage current creates an imbalance that is detected by ground fault circuit interrupter, or GFCI, breakers, causing them to trip. Identifying the specific cause of frequent tripping requires systematic troubleshooting. Start by unplugging or turning off any appliances or devices on the affected circuit. Then reset the breaker. If it trips again immediately, it suggests a short circuit or ground fault. If the breaker holds, gradually plug in or turn on devices one at a time to see which one causes the breaker to trip. If an appliance is suspected, have it inspected by a qualified technician. A breaker that does not trip when it is overloaded or there is a short circuit is a major safety hazard. This failure to trip means the circuit protection mechanism is not functioning correctly, potentially leading to overheating of wires, insulation damage, and even electrical fires. Several factors can cause a breaker to fail to trip. Firstly, the breaker itself might be defective. Over time, the internal components of a breaker can degrade, causing it to become sluggish or completely inoperable. Secondly, the breaker could be of the wrong type or rating for the circuit. Using a breaker with a higher amperage rating than the circuit wiring is designed for can prevent it from tripping even under severe overcurrent conditions. Thirdly, there might be loose connections within the breaker or the electrical panel. Loose connections can create resistance, generating heat that further degrades the breaker's performance and prevents it from tripping properly. To test if a breaker is functioning correctly, a qualified electrician can use a circuit breaker analyzer. This device simulates overcurrent conditions and measures the breaker's response time. If the breaker fails to trip within the specified time, it needs to be replaced immediately. Regular inspection and maintenance of the electrical panel and circuit breakers are crucial for ensuring safety and preventing electrical hazards. A buzzing or humming sound coming from a circuit breaker is not normal and may indicate a problem. This sound is often a result of loose connections or arcing within the breaker. Loose connections create resistance, causing the current to jump across the gap, which generates heat and audible buzzing. Arcing, which is the electrical breakdown of a gas that produces an ongoing electrical discharge, can also occur due to corrosion or deterioration of the breaker's internal components. The buzzing or humming sound is the sound of the electricity jumping, like a miniature lightning strike. Ignoring a buzzing or humming breaker can lead to serious consequences. The heat generated by loose connections and arcing can damage the breaker itself, as well as the surrounding wiring and components. Over time, this can cause the breaker to fail completely, potentially resulting in a fire. If you hear a buzzing or humming sound coming from your electrical panel, turn off the affected circuit immediately and contact a qualified electrician. Do not attempt to repair the breaker yourself, as this can be dangerous. A breaker that is hot to the touch is a definite warning sign of a problem. Under normal operating conditions, circuit breakers should remain cool. Excessive heat indicates that the breaker is working harder than it should be, or that there is a fault within the breaker or the circuit it protects. There are several reasons why a breaker might become hot. An overloaded circuit is a common cause. When too much current flows through the breaker, it generates heat as a byproduct. This is especially true for older breakers, which are less efficient at dissipating heat. Loose connections within the breaker or the electrical panel can also cause excessive heat. Loose connections create resistance, which generates heat as current flows through the connection. Internal damage or degradation of the breaker's components can also lead to overheating. If the breaker's internal mechanisms are worn or damaged, it may not be able to handle the normal current load without overheating. A hot breaker is a fire hazard and should be addressed immediately. Turn off the affected circuit and contact a qualified electrician to inspect the breaker and the circuit it protects. Do not attempt to cool the breaker down with water or other liquids, as this can create a shock hazard. Discoloration on the terminals or around the body of a circuit breaker is another visual sign that something is wrong. Discoloration is often a result of overheating, arcing, or corrosion. Overheating can cause the plastic casing of the breaker to discolor, often turning it brown or black. Arcing can leave burn marks or scorch marks on the terminals or the surrounding area. Corrosion can cause the metal parts of the breaker to rust or develop a green or bluish tint. Any discoloration on a circuit breaker should be taken seriously. It indicates that the breaker has been subjected to abnormal conditions and may be compromised. A discolored breaker may not be able to provide adequate protection in the event of an overcurrent or short circuit. If you notice discoloration on a circuit breaker, turn off the affected circuit and contact a qualified electrician to inspect the breaker. The electrician will be able to determine the cause of the discoloration and recommend the appropriate course of action, which may involve replacing the breaker. Rust or corrosion on the terminals or around the body of a circuit breaker is a sign of moisture exposure or chemical contamination. Rust is a reddish-brown coating that forms on iron or steel when it is exposed to oxygen and moisture. Corrosion is a more general term that refers to the degradation of a material due to chemical reactions. Rust and corrosion can damage the breaker's internal components, leading to malfunction or failure. They can also increase the resistance of the connections, generating heat and potentially causing a fire. If you notice rust or corrosion on a circuit breaker, turn off the affected circuit and contact a qualified electrician to inspect the breaker. The electrician will be able to clean the corrosion and determine if the breaker needs to be replaced. In areas with high humidity or corrosive environments, it is important to protect circuit breakers from moisture and chemical exposure. This can be done by using enclosures that are designed to be watertight or corrosion resistant. Loose connections on a circuit breaker are a common cause of electrical problems. Loose connections create resistance, which generates heat and can lead to arcing, voltage drops, and even fires. Loose connections can occur at the terminals where the wires are connected to the breaker or within the breaker itself. Vibration, thermal expansion and contraction, and improper installation can all contribute to loose connections. To check for loose connections, turn off the power to the circuit breaker and carefully inspect the terminals. Look for signs of corrosion, discoloration, or melted insulation. Use a screwdriver to tighten the screws in the terminals, but be careful not to over-tighten them, as this can damage the breaker. If you find any loose connections, it is important to address them immediately. Loose connections can cause a variety of problems, including flickering lights, malfunctioning appliances, and electrical fires. If you are not comfortable working with electricity, contact a qualified electrician to inspect and repair any loose connections.